All right, in today's video, I'm going to go over how to find the total net force, what is sometimes called the resultant force. And so here on the screen, you can see we have two forces, one at 60 degrees, and it's 40 Newton force, and we have a 70 Newton force at 80 degrees. So the first thing we're going to do is find the components of those forces. And so I'm going to draw some component arrows that I've labeled dBy, dBx, dAx, and dAy. That really should have been labeled force AY, but I'm not going to change it now. So at any rate, we have those drawn, and so then we'll use trig to find their values. So dBy would be, since it's the opposite side, we're going to use sine. So it's 40 sine 60, which works out to be 34.64 newtons up. And then for Bx, that's the adjacent side, so we're going to use cosine. So that's going to end up being 20 newtons to the left. For Ax, it's the adjacent side, so we use cosine again. And so that's 70, or that ends up being 12.16 newtons to the right. And lastly, we end up with AY, which is 68.94 newtons down. So next I'm going to find the total X and total Y. So since I'm going to make left the negative direction and right the positive direction, and up the positive and down the negative. And so what we see here is I have 20 newtons to the left, that's going to be negative, and 12.16 newtons to the right, which will be positive. So there's my 12.16 minus 20. So my total force in the x direction is going to be 7.84 newtons, negative 7.84 newtons, which is the same as 7.84 newtons to the left. Y similarly is 34.64 newtons minus the downward force of 68.94 newtons. That gives us a net force of negative 34.30 newtons, which is the same as 34.30 newtons down. So I'm going to draw this out. We have 7.84 newtons to the left and 34.30 newtons down. I'm going to add then the hypotenuse to this, and that hypotenuse represents the net force, which is also might be called the resultant force. So the resultant is just a way of saying the total value from combining various vectors. So we would just simply use Pythagorean's theorem to find the magnitude of that resultant or net force. And we would get 35.2 newtons, rounding to 3 sig figs. And then we'll use trig to find the theta. So in this case, and I neglected to do the algebra here, but tangent of theta would be equal to opposite over adjacent. So tan theta equals 34 over 7.84. And so I need to get theta by itself. So to do that, I would take the inverse tangent of both sides. And so hopefully on your calculator, you'll actually have a button that looks like tan -1, which is on the screen. That's what you would use. So once I take tan -1 of both sides, I get theta equals tan, or inverse tangent of 34.30 over 7.84, opposite over adjacent. And we get that it's going to be 77.1 degrees below the negative x. So that's the total net result of those two forces that we saw initially. And we know then that we could balance these two forces by one force. And based on the fact that the net, or the total of this, is 77.1 below the negative x, we know that we could balance that then with a 35.2 Newton up and to the right, 77.1 degrees above the positive x. So here's the basic steps for finding the resultant of a vector. Find the x and y components for each vector. Find the total x and the total y. draw a triangle using the total x and total y for the sides, find the hypotenuse of that, and then find the angle.